Hi, my name is Ajay Vashisht and I'm a credit and market risk consultant. In today's topic, we would cover chi-square test. Now, this topic will be divided into three parts. In the first part, we would cover basics of chi-square test, and later on, we would try to understand the applications of chi-square test. Now, chi-square test is used to determine whether there exists a difference between observed value and the expected value. Till now, we have covered tests like z-test or t-test, which were based on the assumptions of data is normally distributed from which samples are drawn. But when it comes to chi-square test, there is no such assumption like data has to be normally distributed. Rather, we would say that the chi-square distributions are positively skewed. And the skewness, the degree of skewness keeps on decreasing and the distribution tends toward normality as the degrees of freedom within the data keeps on increasing. Degrees of freedoms are basically dimensionality within the data set or number of independent variables within the data sets. Now, chi-square tests are basically considered to be a non-parametric test, whereas Z or T tests are considered to be the parametric test. Now, parametric test has a limitations, you can say, in terms of the assumptions regarding the data distribution. Whereas when it comes to chi-square test or other non-parametric tests, these assumptions regarding the data distributions are not that strict, and thus those tests can be applied on a certain distribution where Z or T might not work. Like a data distribution, like nominal data distribution or ordinal data distribution, we cannot apply t-test or z-test. But when it comes to chi-square test, it actually being used while data distribution is either ordinal or nominal. Now, moving on to the calculation of chi-square test, it's very simple. It's simply summation of the square difference between the observed value and the expected value and divided by the count of expected value. Till now, we have understood that there are no assumptions regarding the data distribution while calculating chi-square test. But still, while we build the table for the calculation of chi-square test, there are few restrictions, like data cannot be in terms of percentages. It has to be in terms of frequencies. And the two groups which are tested while calculating chi-square test should be independent of each other, and the frequency, the count in each and every cell should at least be 5 or more for the 80% of the cells while calculating chi-square tests. So these are very basic assumption restrictions we have to take care of while calculating chi-square tests, which we would look into while actually we calculate chi-square statistics. Now, we in the next topic we would cover applications of chi-square tests like goodness of fit test or chi-square test of independence.